One.
Hello, today I am going to show you a tutorial on graphing lines using your TI-83 or TI-84 calculator. This is geared towards my pre-algebra and algebra students. So you can see here on my screen, I have my TI-84 Plus Silver Edition calculator, but any calculator that has the TI and is able to graph pretty much has the same keystrokes. So the first thing you'll want to do is you'll want to turn your calculator on, and this original screen here, this is considered your home screen. This is where you do, typical calculations. Um, in order to graph using your graphing calculator, you have to access this button up here called, we call it the y equals button. If you go into y equals, this is where you enter your equations that you're going to graph. Now, the first thing you want to check is to make sure that your y equals screen is empty and cleared so that there are no equations in there. So you can see here, I have an equation in y2. So I'm going to scroll down and hit clear. Now, it does appear that they're clear, but sometimes you'll need to scroll down a little further. Let me put my large screen on. And you can see here, I actually have something in the Y0 um, area. So sometimes if your little brother or sister or niece or nephew get a hold of your calculator, you'll find little secret things in your calculator you didn't know were there. Okay, so I always like to enter my equations into Y1. Start with y1 and work my way down. So we know that equations are in the form of linear equations are in the form of y equals mx plus b. So for example, y equals x. Y equals x is one of the most basic functions that you can graph. It's a linear function. So located under the mode button is sort of the variable button. You can see it has an X, a T, a theta, that's a Greek letter we use with angles, and an N. And so that's sort of your universal button for variables. So I would like to graph the equation y equals x. Once I have my equation in, I hit graph. And you can see there is my graph of y equals x. For every y value, x has the same value. For example, when y equals 1, x equals 1. When y equals 2, x equals 2. Now, let's try graphing something a little more complicated. For example, y equals x plus 3. Now, through what we've studied with linear functions, you probably can anticipate what's going to happen to this function, this line, before we graph it. We know that our slope is 1 and our y-intercept is 3. So just as we thought, now that line with the same slope has shifted up 3 units on the y-axis. All right, let's graph one more line. Let's do something a little more exciting. Let's graph y equals 4x plus 20. Whoa. Okay. So because our slope is 4, we know that we have a steep line. And what we cannot see on this graph is the y-intercept. And the reason is because it's far off the page, somewhere up here. So this is where we have to do a little of our own thinking. And what we need to do here is change the window. This button here is called your window button, and this is where you change the scale of the x and y axis. So I'm going to go to window here. This window is what we call a standard viewing window. The x minimum is -10 to a maximum of 10. Y minimum is -10 to a maximum of 10. And then the scales are going up by 1. So I know that my equation is plus 20. So I need to be able to see to 20 or maybe a little above 20. So I'm actually going to come here to my y max, and I'm going to change that to 30. And notice I'm just using my arrows, up and down arrows, to move throughout this window. Now, y scale is 1. I'm going to change my scale to, say, 5. That way I don't have all of my increments are not smushed together. So now that I have this window changed, I can just hit graph again, and you can see that my scale has changed. Notice my y-axis goes up much higher than my x-axis, and now I can see my y-intercept is 20. Okay. Another feature when you're graphing that's interesting to see is what we call the table. Right above the graph button is the table button. So if I hit anything in blue on this calculator, if you want to access anything in blue, you have to hit the blue second button before you hit that button. So if I want to access table, I hit second, and you can see that arrow up there. That means that the second button is activated, and then I hit graph. So what this table provides you with is an XY t-chart of every value of y given each value of x. And what I wanted to show you here is right here, there's our y-intercept. We can see that when x equals 0, y equals 20. Every x value has a y value, one y value, which means that this is a function. One last thing I'd like to show you before we go is different zoom windows when you're graphing. So I'm going to go back to y equals, and I'm going to go back to our original linear function, y equals x. And I'm going to hit graph. Now you can see I'm still on my last viewing window, and that may not be what you want. So there's another button here called zoom, and zoom is where you can change the window to some more typical standard windows that you may want to look at. So if you hit the zoom button, you can see here number 6 is Z standard, zoom standard. That is your standard viewing window that you saw in the original line, -10 to 10. You have two choices. You can either arrow down to that and press enter, or you can just press the number 6 and it will bring you right to the graph. There's an interesting thing here, though, that I want to point out, and that is that our viewing window is not a square. It's actually a rectangle. So you can see that even though we go from -10 to 10 and -10 to 10, these x values are actually more spread out than the y values. So it's actually not an accurate picture of what this graph looks like, because the x values, you can even see in the slope of the line, these little x values are just a little bit longer than the y values. So what you can do to get a completely accurate viewing window is you can choose zoom square. Zoom square will make it so that basically each pixel of the calculator is equal both vertically and horizontally. So I'm going to select 5. And do you see how my line changed? It's the same line, y equals x, but you can see now it's accurate in that every horizontal shift is equal to the vertical shift. Okay, thank you for watching my video on graphing lines on the coordinate plane using the TI calculator. The next video, if you'd like to watch, will be on graphing 2 lines on the coordinate plane and finding the point of intersection. Thank you.